by way of intro. There we go. Sorry, just a couple logistics first. So in the interests of keeping background noise down, I've got all participants muted. So you can hear me, but I can't hear you right now. I do invite participation questions during the session. So if you do have a question or want to make a comment, if you could please do that by chat. There's a chat function inside Zoom, and just enter the question, and I will get back to you kind of at an appropriate point. I'll kind of collect things until the end of a slide. All of the slides will be made available to you after the presentation. They'll be sent out, and a recording of this session will also be made available shortly after the presentation. So, by way of introduction, where's my cursor? There we go. My name is Brad Brown. I'm an instructor and a consultant with WebAge Solutions. My practice revolves primarily around architecture, enterprise, and mostly solution architecture. I deal with kind of IT management and strategy issues as well, and development tooling, and increasingly DevOps. My IT background has been largely with Loblaws. I spent 18 years of my career at Loblaws doing literally everything there is to do in IT, from writing code and running software development teams to having responsibility for applications development nationally, and at various times also operations nationally. So I bring to this an architecture perspective that's enterprise focused and pretty broad in the kind of issues that people will deal with. In the roughly 10 years since I've been outside of Loblaws, I've done a number of things, had some interim C-level positions in much smaller organizations dealing with technology, and again, primarily focused on solution and enterprise architecture in the retail space, in the financial space. And what we're going to talk about today is how we got to the place that we are in architecture. There's a journey, a kind of path that computing and architecture has been following, computing path from monolithic systems to extremely distributed systems. And this journey has introduced to us and informed a number of challenges that architects deal with. Now, there are lots and lots of challenges that architects and architecture have in modern enterprise computing. I've selected only some of them. Some of the things that we run into frequently, that I run into frequently in my architecture practice, are around Agile. Agile software development methods and the need to be able to create and develop software in an incremental evolutionary way. DevOps, extending the notion of Agile into a continuous flow process for delivering software into production, and the kinds of things that does to the architecture of an application, and the things that architecture can enable to make DevOps work better. We see the tremendous rise in the popularity of containers, kind of like lightweight virtual machines that we can use for packaging things that also have architectural implications. And similar, but not exactly the same thing, microservices as a movement. Some might say an architectural movement, but development practice movement towards being able to leverage capabilities across an organization in a more easily to manage and deploy fashion. All of these things have significant implications for architecture. So how did we get here? Well, the architecture journey really starts at the beginning of computing, enterprise computing, with monoliths. And I'm using this idea of a monolith as a bit of a generalization. But since back in the day, literally the 60s, we've had applications that we can treat as kind of a big lump, a monolith. And monoliths as an architectural style, they're kind of simple, they're easy to deal with in many respects. And they fit very well with the technology at the time. In fact, monoliths are still very prevalent, very common inside enterprise computing today. And there's really nothing wrong with that. One might kind of say monoliths they're where we kind of learned how to do enterprise computing properly, how to kind of scale to be able to deliver the needs of business. But monoliths have some challenges, particularly in their ability to take advantage of some of the emerging capabilities in computing, which led to the rise of distributed systems. And as computers became smaller and more available, networking became more prevalent and more capable. we started to be able to take advantage of that through distributed systems that, one might suggest, if you kind of excuse my my artistic impression, are kind of like collections of monoliths that work together. That's a fair way of looking at them. And for a while, this has been an effective way of being able to increase our enterprise capabilities. It too has some limitations, and we've tried to get over some of those limitations by looking at other kinds of architecture. And for a while, a popular form of architecture was to look at a service-oriented architecture. The promise of service-oriented architecture, or SOA, was that we could start to think about our systems as lots of little things, lots of little services, which we could compose together into applications and have those services hopefully be reusable across multiple applications, and kind of think about our business and our compute capabilities in terms of much smaller and hopefully easier to manage units. Well, that was kind of the promise. What actually happened in many respects was we got overwhelmed with complexity, probably much more so than the graphic illustrates. Where SOA was really widely deployed, and of course this is an overgeneralization, but in many cases where SOA was deployed, we got into this state where we had all these services that all connected together. Each of the individual services might have been small and fairly easy to manage. But what we missed was it was the complexity of the connection and the interconnectedness and the coupling between things that led us to a kind of a very difficult to change and difficult to manage world. Now, somewhat in parallel with that, we've also seen the emergence of cloud. And for many organizations, cloud is the new hope. And there are lots of very successful organizations who've built significant capabilities on cloud. And in many respects, cloud is the future for many organizations. The challenge with cloud, and why I didn't select that as one of our current challenges, is because the corporate reality in many cases is, again, if you'll excuse the artistic impression, that cloud is a little bit of pink clouds and unicorns. This is supposed to be pink clouds and unicorns. In the sense that in many organizations, the reality is, for lots of good or maybe not so good reasons, the organization just isn't ready to really move into cloud in any kind of big way. So this journey that we're on has brought us to a place in architecture where we have a lot of really interesting challenges. And some of the significant challenges, they really flow from this journey that our industry has been following on. And again, the challenges that I see commonly in practice are around how we as architects deal with able and assist to is being able to, well, what about this and what about that? And there are all these other things that we could be talking about as well. And of course there are. The big one, of course, is cloud. And again, cloud is a big enough topic that I've simply chosen not to address that here, just because there's so many organizations that are just not quite in that state yet. These four topics are probably the top four things that we see coming up over and over as significant challenges for architects. So let's look at each of those. So Agile. Agile presents some interesting challenges for an architect. And the whole point of Agile, or a whole point of Agile, is that we want to have a development process that allows us to move away from having very, very infrequent, very large changes to having frequent, small changes. Back in the day, we would develop applications on 6, 12, 18-month cycles. We go through a fairly linear process of requirements gathering, design, development, test, deployment. And as architects, we had a well-defined place in determining what that was to look like, particularly what the design should look like. Now we're in a world where the applications that are being developed are changing very frequently. There's also often great pressure to jump right into building the application. Now, this is a little bit of a cultural thing, and sometimes is a bit of a maybe misunderstanding of what Agile is supposed to be all about. But there's certainly a cultural imperative in many organizations that we need to be able to start building something right away. In this context, it's not really always clear how architects can participate in the process. And again, some of this is cultural, some of it's also about the methodologies themselves. Sometimes Agile methodologies, they don't really take into account architecture as kind of a first-class activity. Or they do, but you have to read between the lines to find it. Or the way that it's taught, practices that people follow, don't really emphasize architecture enough. So we're left with a challenge. How do architects really participate in the larger project, particularly when that project, that product that's being developed, is changing over time, that the evolution of the system that's being developed using this Agile methodology is something that is constantly evolving. There's constant change. And how do architects keep up with that? In two respects, not just understanding what an Agile team is doing, but how do we contribute to that? How do we kind of participate in that process? And if you kind of read between the lines in these challenges, I think what should be apparent is these are all kind of process things. They're process challenges. We haven't said anything that says we do architecture, that the architecture we develop should be different, just the process is different. So what do we do about that? Well, there's kind of no magic answer. There's no magic fairy dust we can sprinkle on the problem. But I can suggest a number of good practices that we observe as being effective in helping architects and Agile teams work together. And one of those is to actually do solution architecture. Now, this may seem kind of stunningly obvious. Of course, one would do solution architecture. But it's actually, in a lot of organizations, it's not so obvious that solution architecture should, at some level, at least at a high level, should actually precede an Agile development of a particular product. And the good practice here is that having a solution architecture, having at least a high-level solution architecture, actually is a very beneficial thing. A lot of the resistance can be, it's that I want to jump into building. A lot of the resistance can be, let's get started. And it turns out that actually having a solution architecture as a framework, as a kind of overall set of guardrails to how an application can be built, will actually accelerate the Agile software development process. It will actually accelerate the realization of value. And it will actually diminish the amount of kind of rework that goes on. But the big thing, this is the really big thing, is without a solution architecture, there is always a risk that an Agile software development project will end up delivering something that works. It will meet the functional requirements, but it will meet it in a way where the architecture of the underlying, the as-built solution is emergent. It is what it is because that's the way it was built. And these emergent architectures tend to be brittle, hard to change, don't anticipate the future. They're not amenable to ongoing evolution. So there's a tremendous value in actually doing a high-level solution architecture, even in an Agile practice. So how do we do that? Well, one way of doing that is sprint zero. That's a zero, not an O. It's not sprint-o, it's sprint zero. And sprint zero is a particular thing. I'm using it a little generically. The idea here is that before we actually start into development, we have an Agile team. We have the team assembled. Everybody's ready to go. They're ready for their first sprint. And a sprint results in working software. That's kind of the idea behind a sprint. Well, the idea behind sprint zero is we have this initial sprint that actually doesn't result in working software. It results in another side effect, an understanding of where we're going, what the framework is, what the architecture is. And this sprint zero is this is a place in the process that an architect can kind of latch onto and use this is where we deliver the architecture, kind of explain the overall vision of the product, kind of how the architecture works. And essentially it's allowing us to kind of point the team in the right direction. And that's a great way of injecting that architecture into the beginning. But then after that, another good practice is for architects to actually participate throughout the process. Now, there are often a lot of organizational challenges with this, but in an ideal world, we'd have architects who are able to participate in sprint planning and participate in the retrospective. An architect can contribute to the sprint planning process because they have a unique perspective on how all the components of a solution fit together and how their realization can affect the realization of components that people are going to work on later. And they can really help in the sprint planning process by guiding the selection of the right things, the right stories, the right functions, whatever kind of thing you want to have as your backlog items. And really help people move towards an overall solution in a kind of rational and effective way. And by participating in the retrospective, it gives the architect a chance to see what was done, what some of the challenges were. They can take that and they can do two things. They can update the architecture of the overall solution if they're the people who are documenting it. But more importantly, they can recognize the challenges that the team has discovered, that the Agile team has discovered, and that gives them a chance to say, I'm going to put an architectural lens on the solution to that problem and help you with kind of moving that forward. The common thread here in the Sprint Zero and participation is that as an organization, the organizations that do this well, we see having a cultural shift in the role of architecture. Now, this is a challenge kind of shift in how Agile teams think, but it's also a significant shift for architects. The idea that for an architect that they're not kind of producing an architecture and kind of walking away, that they're actually producing the beginnings of an architecture and then participating in its evolution is a significant shift in how a lot of architects think. However, it's also very liberating. It's also kind of very rewarding. And if it's supported by the organization, can really enhance both the practice of architecture and the agility of the organization itself. So another challenge that we face in modern enterprise IT is DevOps. Now, not everybody's doing DevOps, but I tell you, everybody's moving in this direction. And the idea behind DevOps is that we're essentially creating a uniform continuous flow process that in an ideal world would go right from checking in new code all the way to that code being built, tested, deployed into various lower level environments, eventually ultimately ending up in production, hopefully all through automation. Now, what this means is we're building and testing often, building and testing very, very often. And for an architect, you might say, well, that's not really a big deal for an architect. The architect can have a significant positive effect on the buildability and testability of a solution, particularly testability. If we're going to test often, that means the tests have to be automated. And we can provide architectural elements, hooks, into the application at the architectural level to support testing. Simply identifying what components really need testing interfaces is a significant positive benefit that an architect can provide. Now, this build and test, it's an important piece of thinking about architecture, but it's kind of not the big piece. There's another piece. It's kind of a really significant change. And a side effect of this is we also want to be able to deploy small changes often. Again, very often. Now these changes, they're not going to go to production. Well, they'll go to production once in a while. But before they go to production, they'll go into other environments like a SIT, QA, some test environment, UAT, whatever it happens to be. And they'll be deployed in that environment very often. So this focus on being able to deploy small changes is important. And this is important for an architect. An architect who designs a system, designs a solution, thinking about issues like what components will be able to be deployed and how are they divided up to be deployable, to be able to manage in a kind of automated deployment environment. That can have a significant effect on the ability of the delivery team, to be able to actually build and automate the deployment process. So an architecture actually has a significant effect on how effective we can be at being able to deploy. So an architect really should have a good understanding of what the whole deployment process and environment is. And this is really all in support of a larger trend. Remember that journey? We went from monoliths to distributed components to, well, I said microservices here. I'm kind of tipping my hand for a later topic. The idea that we're starting to deploy smaller and smaller pieces more and more frequently has significant effects, implications for an architecture if we're going to design something that kind of fits into that world. So what are some of the good practices? There we go. What are some of the good practices that we see architects doing to contribute positively to DevOps? Well, a big one, really big one, is architecting for independent deployability. Now, this doesn't sound like a big thing, but it's actually kind of a subtle effect. It has a subtle but important effect on your overall architecture. To actually think about what are the units of deployment and think about that relatively early on can have a significant effect on the ability to build, test, and automatically deploy a solution. Now, one of the things that enables that is the use of message-based communications. So between components, having a messaging infrastructure and using that messaging infrastructure for communication is not essential. It's not a must-do, but it's an enabler of independent deployability. It's an enabler of a bunch of things, actually. And the more we can move toward message-based communication in our systems, the more we'll be able to manage them effectively in the DevOps environment. Again, I use the word favor very deliberately because it's not a requirement, but it certainly makes life kind of easier. When I say message-based communications, I'm also including in that REST-based communications. So I am not saying you have to use like message queuing or something like that, but the loosely coupled communications, standards-based communications, very, very valuable for making DevOps kind of more practical. Now, a side effect of that, or result of that, is as an architect, it's important to focus on interfaces. Now, that should also seem obvious, but it's this focus on interfaces goes hand in hand with this idea that we're using loosely coupled communications. And it goes hand in hand with this idea that we're architecting for independent deployability. All of these are enablers of practices that benefit the DevOps process. Which kind of leads to my last good practice here: participate in the deployment pipeline. What I mean by that is architects should really understand how deployment works, what the pipeline's like, what the environment's like, how these DevOps processes are actually realized, and hopefully be able to participate in their creation. Maybe not kind of writing the code behind them, but kind of work with the team as a stakeholder in the DevOps process. Maybe participation is a little strong, but certainly understand the deployment pipeline is an important aspect of really being an architect who can contribute positively to enabling DevOps. Now, this DevOps practice, a lot of things that we deal with in DevOps, are really about kind of packaging and being able to deploy packages of capability into an environment. And another trend that's increasingly common that we see in our practice today is the move towards containers. Now, containers is kind of like a lightweight virtual machine. Now, containers are a really interesting concept, and if you're an architect who hasn't really dealt that much with containers, I want us to take a couple minutes to really talk about a little bit about what they are and why they're important. So the backstory behind containers is, well, think about what's happened in the evolution of computing kind of following a little bit about that journey, but in a slightly different perspective. We started back with machines that we'd actually buy machines and we'd rack them and we'd install an operating system on them and we'd kind of run them. And the operating system would be running on the bare metal. And so there was a kind of one-to-one correspondence between a physical machine and the operating system that we could actually do something with, the host that would host our applications. And this was great, but it wasn't really very flexible. So along come virtualization. And we start to build out virtual machines. And a virtual machine gives us the ability to take a piece of physical hardware and pretend that it's actually broken up into 2 or more smaller pieces of hardware. We could take a physical piece server and actually run 2, 3, 4 separate operating systems on it. Now, why would you want to do this? Well, one reason I'd want to do this is because I get better utilization of the hardware. And there's a whole kind of practice around being able to effectively use hardware and what it does for operations in a data center. That's a little bit, it's fascinating and important, not quite where I'm going though. But the other thing that I can do with a virtual machine is, if I can afford to have more of them, have smaller virtual machines, then I can do something that's architecturally important. I can take a component of my application and I can deploy it inside a virtual machine, and the virtual machine is used as an isolation layer. So the deployment of my component, my application, it's isolated inside the virtual machine. And in an ideal world, I take each major component to my application and I deploy it inside a virtual machine all by itself. Now, why would you want to do that isolation? Now, it may not be apparent from an architect's point of view, but from a kind of bigger picture deployment and operations point of view, there's actually a lot of benefit to being able to take pieces of an application and deploy them separately. Consider the classic 3-tier application where I have a, say, web server, business logic layer, and a database. I can take those 3 components and I could deploy them inside a single machine. Virtual or physical, not really important, inside a single instance of an operating system. And that's fine, but there are a few things that happen when I do that. Because I've got those 3 components, and they're all existing in the same environment, I have a configuration challenge. Something that I do to configure for one part of that component might conflict with configuration requirements of another component. It's harder to manage 3 things, particularly the evolution of those 3 things, if I have to patch things, upgrade packages, whatever, when they're all together, because any change that I make can affect something else. So it's much harder to manage the environment, and particularly to manage the environment over time. So another kind of aspect of putting these 3 components in one place is that they can affect each other. They can step on each other's toes. Maybe I do something that the database really, really requires a lot of resources. Well, that consumes resources from the other things. And if I don't have mechanisms for controlling that, I could have one component effectively starving another component for resources. It also becomes much harder to scale this environment. What happens if I need more of these? I need maybe more web servers, but I don't need more of the other things. I can't just make multiple copies of this. It's not architected for that. So a solution is to take each of those components and actually deploy them separately in separate virtual machines. And this is very attractive because then I can take each of the components and optimize the configuration of that virtual machine for that specific component. Makes configuration simpler, makes maintenance simpler, upgrades, package management. Everything becomes simpler because I don't have these conflated concerns. It also makes it simpler to be able to scale the environment. If I need more application servers, but not more of anything else, in principle at least, I could just create some more virtual machines that have application servers in them. Now I have to wire them up, but let's assume that's a solved problem. So there's kind of a lot of attractiveness, should be apparent. There's a lot of attractiveness to being able to use virtual machines as a way of isolating a deployment and configuration. But there's a problem. Virtual machines are very heavy in the sense that a virtual machine contains a complete copy of an operating system. So I have a whole operating system I need to maintain. But not only that, that operating system, when it's running, takes significant resources, particularly memory. Running operating system, there's a lot of RAM memory just consumed in keeping track of what that operating system is doing. I also have a lot more operating systems to manage. There's some complexity in that. But it's that resource overhead that's kind of a real issue that limits my ability to actually deploy lots and lots of virtual machines. And in many organizations, remember I said a lot of organizations, they're not ready for cloud yet. The ability to just spin up virtual machines is really kind of limited for very good reason. So it's kind of hard to just say, I want to make a new one on the fly. So with this kind of longish backstory about the benefits of isolation, with the challenges of virtual machines, now comes containers. What a container is effectively a virtual machine with none of the overhead. It's a little bit of an oversimplification, but what happens in a virtual machine is what happens in a container is we have a mechanism whereby we can put some processes running software inside a container. And the software that's running inside a container, the processes that are running inside of the container, they have a kind of boundary around them, kind of, let's say the edges of the container. And the boundary is such that the processes inside the container, they think that they're in a machine all by themselves. Because that boundary, the container walls, what it's effectively doing is isolating the processes inside the container from processes outside the container. And it does this through a whole bunch of smoke and mirrors. It's all trickery, but it's done at the operating system level, to the point that when a container performs an operating system operation, when it makes a syscall, it's protected by the kernel from seeing anything or affecting anything that's outside the container. There's more subtlety than I really want to get into here about how this actually works, but the nut of it is it works really well, to the point where containers give me really all the advantages of virtual machine. The things inside a container are isolated from things outside the container. And containers can contain a configuration in the sense that I could put software in a container and I could actually configure that container by running things like a package install or installing software inside the container, setting environment variables, whatever it happens to be. All that configuration is encapsulated inside the container. Now you may ask, but really, what's the difference? Containers don't have their own kernel. What happens is there's an operating system, and the operating system can run, through container management software, a number of containers. And every container thinks that it's isolated like a virtual machine, but there's no overhead, because there's no additional kernel. I don't need extra RAM. There's no kind of startup time. They're very, very efficient. What this leads to, so I get to the next bullet eventually. What this leads to is containers are a way of encapsulating an application, but not just the application, also its configuration. And this is fantastic because it really solves a lot of issues. One of the big issues it solves is if I'm going to take a component of my application and deploy it somewhere, in the kind of pre-container world, what I'd have to do is put it someplace and configure the things around, the things in the place I'm putting it. I'm going to put it on a QA machine, but I also have to install some packages, install some software, set some environment variables, yada, yada, yada. And that now I'm back in that same problem. How do I repeat that configuration somewhere else? And how do I deal with the fact that I might actually need multiple things running on that same machine whose configurations might actually conflict? In a container world, I simply take the component, package it in a container, and deploy it into an environment. And all that configuration goes with it. So these containers then are very, very attractive as a unit of deployment. So for an architect, this presents a little bit of challenge, not too much. It's actually kind of the same from an architectural point of view as deployment into a virtual machine. How do we talk to things in a virtual machine? We have to do it by networking. Same thing as a container. How do we kind of package up configuration? Same thing inside as in a virtual machine. It's part of that kind of deployable unit. So as an architect, we can certainly think about containers as a way of achieving this. Well, here's how I think about deployability. But there's another change. This is a really important challenge. And this is another one that's very important for architecture. There's a trend, desire, to have what are called immutable containers. The idea behind an immutable container is exactly what it sounds like. When the container is created, I never change it again. In fact, some containers are so-called sealed, in the sense that once you create it, you can't even look inside, or you don't want to look inside. We never can change a container. We just build a new one and throw away the old one. So the scenario that you'd actually see is, I have version 1.0 of software. It's been deployed. It's running inside a container in some production environment. And we decide, well, we're going to roll out 1.1. So what do we do? Well, actually what we do is we create the 1.1 version of the container, we deploy it, we throw away the 1.0 version, and we just start using the 1.1 version. The 1.01 is immutable in the sense that we never actually change it. We don't deploy a new version of software into the container. We destroy the old container and roll out a new one. Now, this doesn't sound terribly exciting. What's the big deal in that? From an architectural point of view, this is important though, because there are a whole bunch of implications to this idea that containers are immutable. And one of those is, well, we can't actually change anything in the container if it's immutable. So we can't keep state inside the container. Now, this isn't a hard and fast rule, but for the container to be truly immutable, you can't actually rely on anything being inside the container for any length of time. Because in principle, a container could just be thrown out at any moment and a new one deployed. This has significant architectural implications. It means a number of things. I need to be able to keep state outside the container. So a database, for example, the database engine could be inside the container. The actual data has to be outside. But it's even kind of simple stuff, like where do we put log files? They can't exist inside a container because the container could go away. A whole bunch of issues around immutability that need to be thought through from an architectural point of view. But they're important challenges, but the benefits are tremendous. This kind of notion that things are immutable actually solves so many problems. We see this coming up not just in containers, but in many, many places. Even kind of data itself. Immutability solves so many problems, but it is a challenge that architects need to be aware of. Now, I've gone on a little bit about containers because we see them as a critically important thing, that this is the future of deployment for all kinds of reasons that go beyond this talk. So it means that we really should have some good practices as architects for dealing with containers. And one of those is kind of obviously after that introduction, architect for packaging inside a container. And part of this practice around architecting for container packaging is simply understanding this notion of immutability and making good decisions about how components inside a solution architecture are partitioned into things like containers. It also means that we want to be able to think about message-based communication. Okay, we talked about that already. That the message-based communication helps deployment. It also helps containers quite a bit. Another good practice is to think about this idea of one process per container. Now, I should have put this in quotes, because this is actually a little bit of a kind of catchphrase. It's used by the Docker community. Docker is the leading container technology. And the idea behind one process per container is, it's not to be taken literally, but figuratively, a container does one thing. It hosts one kind of useful process. And it's a guideline to breaking up applications into smaller and smaller pieces and deploying those smaller and smaller pieces inside containers. And it has an architectural implication because it drives an application an application's architecture, its solution architecture, to being organized around small components that are loosely coupled and communicate and are individually deployed inside containers. And again, each of those containers should be stateless. That's a good architectural practice. Now, that doesn't mean that there is no state, obviously, but we take that state and we externalize it. So the state isn't inside the container, it's outside. Take these things together, and it gives us the ability to architect for horizontal scaling. What I mean by that is, think back to my original discussion of that application and packaging up into 3 components and putting it inside virtual machines. If we were to take that application, web server, application server, database, package that inside containers, one way we could get horizontal scaling is to be able to say, hey, I've got a container that hosts my web server. I need more web servers. I'd just like to start more instances of that container, please. That's horizontal scaling through containers. We need to architect for that. And the part of that architecture is it's the same thing that you do for architecting any highly distributed system. It's ensuring that the individual components are able to be scaled horizontally, that you can get more throughput, more capacity, simply by providing more copies of them. And there's some good practices around that. Things like, if you can have an application, let's say it's a web-based application, without session affinity, that helps horizontal scaling. And there are kind of common practices around distributed systems that really allow you to scale horizontally that we should really try to be taking advantage of in a containerized environment. And part of the implication for architects here, part of why I'm emphasizing this as a good practice, is you may design a system for container deployment, thinking that, well, I'll only ever deploy one of each kind of container. And you may kind of build some things in that limit your ability for horizontal scaling. Containers really give us an ability to rapidly and easily scale an application, even if we don't have a cloud environment. And because of that, we should be anticipating the horizontal scaling will be probably used in the future. Build it in right away. And the last good practice is recognize the kind of special nature of containers, the fact that they tend to be created on the fly. They tend to be thrown away on the fly. And you may not be able to kind of look inside them. So anything that you need to know about the container, externalize that as well. The common thing that I think is a really good architectural practice is to use an external logging service, something like Splunk, but there are lots of these. So that any events that are happening inside the container that we need to be aware of in the outside world are actually externalized through an interface so that they're not inside the container. You can see them from the outside. Now, I'm mentioning this as an architect because the architect is in a role where they can specify this as part of the overall solution architecture, actually make the operation of the solution, the ability to collect logs, make that part of the architecture. And a big part of the reason for that is if we as architects do this, we help to ensure that there's consistency, commonality in how it's actually carried out. The last of the interesting challenges that I want to talk about today is around microservices. And the trend is towards microservices for core capabilities, but also microservices as a mechanism for breaking down monoliths. So what we see with our clients is there's been lately a tremendous uptick in the interest in microservices. We see kind of 2 primary use cases. Those who are interested in using microservices as a mechanism for breaking down a monolithic application. They've got a big monolith. They need to be able to be more agile in the use of that monolith. So they start to use microservices as a way of chipping away at the functionality inside that monolith, to refactor some of that functionality out into a microservice, and then be able to manage that functionality separately. That's the second use case. The first use case on the slide is to deliver core capabilities. So a microservice for example, customer lookup, or to provide some kind of core capability like, I don't know, rating on an insurance policy. So this challenge that we face as architects is that we have a real need, and we see a need in enterprises for greater agility, greater leverageability, if you will, reusability of core capabilities, and a real business imperative to be more agile in how we deal with monolithic applications. And microservices is the way that this is being handled in a lot of organizations. However, there isn't a really clear definition of microservice. Just what is a microservice? And from an architect's point of view, this can be a bit of a challenge. We see some organizations getting a little bit into religious wars about just what is and what isn't a microservice. But we also see the risk, in some cases the reality, that there's been a proliferation of microservices that really can lead to an unmanageable mess over time. Now, if you go back to the, if you recall the slide that I did about service-oriented architecture and what actually happened, that's kind of the thing that can happen in microservices. The kind of proliferation, deployment of lots of microservices without a lot of management can result in a world where you have lots and lots of things, you don't really know what they're being used for, and you don't really know kind of how they're being managed. So what does this mean for good practices for architects? Well, one good practice is to leverage the good practices, if you will, that we just talked about in containers. Because there's kind of a natural fit between microservices and containers. The things that make something deployable in a container, independent deployability, interface to communicate with it, separate isolated thing, those are all things that microservices need. In fact, a common pattern is creating microservices and then deploying them in containers. So all of those practices that are good ideas around containers, they're excellent ideas around microservices as well. So an architect who understands containers can take those same ideas, effectively translate them into the imperatives of what makes a good microservice. Another aspect of this that's important from an architectural point of view is to focus on extensible and versioned APIs. Now, this is an area where I feel architects are in a unique position to be able to make sure that an organization is doing the right thing with its APIs and with API management. Now, what do I mean by this? Well, a microservice, part of the definition of a microservice is that it's a capability that is accessed through an interface, an API. And that the implementation of the microservice is independent of that interface. In other words, I could change the microservice, leave the interface alone, and no one would notice. Okay, there's nothing kind of special about this. But think of what happens to a microservice as it evolves. I have a microservice for delivering customer information, customer lookup, say. And what if somebody comes along and says, well, now we know something more about customers that we didn't before. And I want to change the API to be able to add that additional customer information. If you don't take an architected point of view of this, if you don't really think this through, then what you'll have when you approach this problem with a bunch of different microservices is a couple things. Well, several things. One thing that will happen is the APIs to the microservice might change. You might introduce breaking changes to the API, which means that when you roll out a new version of the microservice, anybody who's consuming the new one, the old one, they have to make changes before they migrate to the new one. Or if you roll out the new one on top of the old one, it'll break existing clients. Now, there's a practice in API management about how you can actually version APIs or make them extensible as related but different things. And kind of following those practices and specifying them at an architectural level will lead you to creating microservices that are much, much more reusable and much less disruptive as they evolve. But another thing I should have made this a separate point on the slide, that's really important from an architectural point of view is as we have microservices across the organization, effectively what we're doing is we're creating a fairly large number of very small pieces of software that tend to evolve relatively quickly. Now, they tend to be independently deployable, but related. I might have a customer microservice, and I might have a, I don't know, a loan rating microservice that needs some customer information. There are going to be aspects of the APIs, the semantics of individual APIs that overlap between microservices. So one of the things that becomes really, really important in an organization who's going down the microservices path is to have some management over the representation of things in those APIs. If we're going to represent a customer, we should do it in a consistent way. The meaning of elements of an API should be consistent across microservices. Now, microservices tend to be developed by independent teams, and that's a good thing. If we don't have this layer of management, governance, around the meaning of the APIs, it becomes very difficult to ensure that there's any consistency across the organization. And as soon as you lose consistency between microservices, you start to run into lots and lots of issues. Issues like, whose representation of customer is right? Well, how do we translate between one and another? Can we actually kind of make some representation that's common amongst all of these? Now, this is really an extension of some of the problems we deal with master data management. It's a very, very similar kind of issue. But the architect is in a unique place to be able to understand this problem, make sure it's done consistently across an organization, across microservices, and kind of make sure that these APIs are actually effectively usable. Another good practice is to avoid deep layering of microservices. What I mean by that is, it's generally speaking not a good idea to have a service that calls another microservice, that calls another microservice, that calls another microservice. This deep layering is not really any different than what we had in service-oriented architectures, and when SOA honestly kind of fell apart a little bit, part of the reason was this deep layering without managing all the dependencies. For the most part, we want to think about microservices as, I like to think about them as a single layer. So I can have an application that consumes microservices. Microservices, as a generally speaking, don't consume other microservices. That's a simplification. It's a constraint on the architecture. It turns out it's a, it's a rule of thumb, not a law, but it's a fairly good practice for avoiding the situation where we have lots and lots of dependencies that become unmanageable. Now, there's a common thread in a lot of the things I've talked about here that really goes to having strong governance of microservices. And this, I mention this as a good practice for architects because the architecture layer in an organization is a pretty good place to put this governance around microservices. And the governance of microservices is about, what's an appropriate microservice, which ones are appropriate for reuse as opposed to being something that's just kind of inside an application. And most importantly, what's the representation of information? How do we manage APIs in a way that's common across the organization? Now, that being said, I think there's a balance here. We need to be practical. We need to be business driven in what we're doing with microservices and how we architect them and how we manage them. And we have to draw a balance between strong governance to make sure that things are reusable over time and being able to be effective in making use of being able to realize business imperatives at any time. So those are 4 big topics that are kind of challenges for architects. And just in summary, 4 of the things that we see as challenges to modern architecture are the rise of the Agile movement, where the architect really can be in a position to guide an evolutionary development process. The rise of DevOps as a practice across an organization for delivering small changes more rapidly, where an architect plays a role in being able to design solutions that are intended to be deployed in an automated fashion. We see increasing use of containers, where architects really need to be able to think about how to create containers that are independently deployable, and they're immutable, and they're kind of breaking an application into smaller components. Where here, an architect really needs to understand how to take advantage of the technology. And related, but not exactly the same, the tremendous rise in the interest in microservices, where the role of an architect is to be able to architect for small, orthogonal, it doesn't depend on other things, extensible services, and to manage the environment. Now, I'm going to ask if there are questions in a moment. I haven't seen anything yet, but I'll ask if there are questions in a moment. I'm going to leave you with, just on the screen, a number of upcoming classes that WebAge is running in a number of different areas. One specific is Architecting the Modern Enterprise, which is a survey course that deals with a lot of the issues that we've talked about and a number of other ones around how we actually do architecture inside a modern enterprise. We also have a number of courses that are specialized around Agile, Microservices, DevOps. Some of those DevOps have architecture content. And I'd invite anybody who's interested, who hopefully enjoyed this and found this interesting, to peruse the catalog, and there are a number of things that I think would really build on some of the topics that we've talked about today. I want to thank all of you for your time, your interest, let's see. I'm going to open the floor for any questions if anybody wants to ask anything. For those of you who don't, have a great rest of the day, and have a great holiday season as well. Now, I do have a chat message here. Oh, it's so logistics question. Will this be emailed out as well? So yes, I think it's actually going to be a link to the presentation. I don't know whether the actual presentation is going to be emailed, but you're going to get the content, yes. Thank you, appreciate the feedback. It looks like we don't have other questions on content. I'll take that as a sign of good coverage. And again, I want to thank everybody for participation and interest, and hopefully I'll run into some of you in an upcoming course. Have a great rest of the day.